Continuity Part 2. In section 2.3, we said a function f is nice at a if the limit as x approaches a of f is equal to f of a. So the limit of the function is equal to the value of the function. We called those functions nice when they have that property. So all the functions that we formerly called nice, we now know to be continuous. So let's review those functions that we called nice when we were in section 2.3. Polynomials. Polynomials are continuous everywhere. Rationals. Rationals are continuous as long as the denominator doesn't equal 0. And trig functions. If you stay in the domain of the trig function, in those sections where you're in the domain, it's continuous there. But again, like the rationals, whenever you've got 0 in a denominator, that would be a point of discontinuity. Let's do an example of a rational function. Where is this rational function continuous? Well, you may recall from our discussion of nice functions that a rational function is nice as long as its denominator does not equal 0. So for a rational function, we need only find the zeros of the denominator to find points of discontinuity. When we factor the denominator, we discover this function has two discontinuities, one at 4 and one at 3. So we say that the function is continuous everywhere except at those 2 points. In fact, if you recall our discussions about vertical asymptotes, these 2 points represent vertical asymptotes. So this function is continuous everywhere except for it has 2 discontinuities, and both of those discontinuities are vertical asymptotes. Let's continue our discussion. What about trig functions? Well, let's look at a cotangent. If I'm looking at the interval from 0 to 2 pi, where in that interval from 0 to 2 pi, for what open intervals is the function continuous? Well, where is our cotangent function not defined? Cotangent is not defined wherever sine is equal to 0. Sine is equal to 0 at 0, at pi, at 2 pi, at 3 pi, and 4 pi. So when you look at a graph of it, of cotangent, you're going to have a vertical asymptote at 0 and pi and 2 pi and 3 pi. So for this particular problem where I'm only looking at 0 to 2 pi, I say that on the open interval 0 to pi, my function is continuous because there's no discontinuities between 0 and pi. Also, there's no discontinuities between pi and 2 pi, so that's another open interval where it's continuous. However, I can't say that it's continuous from 0 to 2 pi, because from 0 to 2 pi, there is a point of discontinuity right there at pi. But if I break it up into 2 smaller open intervals, 0 to pi and pi to 2 pi, both of those smaller open intervals are intervals on which cotangent is continuous. All right, so what is continuous where? Polynomials everywhere. Rationals everywhere except where the denominator equals 0. Trig functions everywhere except where the denominator is equal to 0. All righty, 2 others, odd root and even root. Let's look at odd root. Odd root functions are continuous everywhere. For example, the function f of x equals the 3rd root of x, that's continuous everywhere. And even root functions, as long as your radicand is positive, then the function is continuous. So f of x equals square root of x, that's continuous for x being positive. What about at 0? Well, we know 0 is in the domain of the function. Also notice that as x approaches 0 from the right, as x approaches 0 from the right, the square root of x equals 0. So the limit of f as x approaches 0 from the right is equal to f of 0. When such a situation as this occurs, we say that the function is continuous at 0, or whatever it is your target point is. So we say that the function is continuous at 0, but we explain coming from the right, because you can't come from the left and the right in this case, only from the right. Now, we furthermore say that it's continuous on the interval from 0 to infinity, including 0. We're going to continue our discussion of continuity in a third video, and I'll see you then.